welcome to our webinar. Well, I want to thank everybody for joining us on EasyCAM's 2024 webinar. We will be covering features that are new to our Turn and Turn Express. My name is Chris Lalashis, and I've been with EasyCAM about 20 years now. I will be your sales and support representative. So let's just go over some of the benefits you're going to get with EasyCAM. You own EasyCAM. It's a one-time purchase where support and upgrades are optional. Subscriptions are now available. Free TextCam. TextCam will engrave any Windows font and machine either on centerline, bosses, or pockets. What a great addition to our Easy Turn with the live tooling. FilterMax. FilterMax is an RS-232 communication software. It also has the ability to optimize programs up to 98%, taking those short line segments and converting them into arcs. 1 year's free support and maintenance is included with your purchase, and that includes purchases of upgrades. Custom interface. You can create toolbars and buttons in EasyCAM that will prevent you from having to drag your cursor across the screen into menus for repetitive tasks. All features are included. There are no additional fees. Turn has rotary axis, indexing, and live tooling. Turn and Turn Express support subspindle, 2 turrets, gang tooling, a Libre CAD, DNC, and simulation. Post-processors and post-processor editing. We supply you with a post-processor library, and if a post is not available, we'll create one for you, and we'll make the edits according to your machine's requirements. We want you to feel confident when you hit cycle start. SolidWorks and a Libre transfer, along with many other extensions, so you can communicate with any CAD system. Custom videos. We have over 200 videos on the web covering various topics. If we didn't cover a topic, we'll be happy to create a video for you. And if you get stuck on a project, send us your project and we'll create a custom video. Wizards. We present you with the least amount of information up front so you can create a complete program. Safety checklist. Down at the lower left-hand side of your screen, you can open the Work Step Manager. Here you can organize tools, offsets, speeds and feeds, and so on for when you post your G-code. Solid models are not required. EasyCAM will allow you to program with geometry. That way there you don't have to revise a model for simple tool paths. So let us begin. We have a skip groove option. We have improved our skip groove feature that when the size of the groove is 10 times the width of the tool or less, EasyCAM will pass over a groove. So let's take a look at that now. So let's see what we have for toolpaths so far. EasyCAM is not skipping the groove, meaning that the tool is less than the width of the groove as well. So we're going to take some dimensions. The groove width is 91.3619. So let's go and change the width to 92 or 9.2. Now the width is strictly for skipping over grooves. It is not the width of your insert. So why might we skip grooves? Well, if you look at the insert, EasyCAM wants to feed into any space that will allow the insert geometry. This may cause chatter or even groove tool deflection. And we do have skip groove checked. Verify our machining again, and we're good to go. Lead and ramp parameters. This feature allows the toolpath to be extended beyond the dimensions specified by the part boundary. We'll look at the front face. As you can see, we are starting off of the edge of the chamfer, but let's add an arc in there and maybe exaggerate the lead a little bit. You do that by going to cycle data, lead and ramp parameters. We'll focus on in, 12 millimeters for radius, 45 degrees, whatever you prefer. And I'm going to exaggerate the lead to 20 millimeters. Here we have an arc moving in, and here's our 20 millimeter lead up to the chamfer. Let's talk about the stock, template management, and our boundaries. Over on the left-hand side, you can see that we're selecting our stock type. Then over here on the next slide, we have our different materials for the part. This will load the corresponding templates because the template needs to be different for aluminum when you're cutting aluminum or cutting bronze. Those are going to be different. Then we have compute, where we'll give you the length of the part and the diameter. And lastly, you can reverse the model if it comes in backwards. All right, the first thing we do with any model is go to 3D simulation. Here are the stock types. We have cylinder, which could be bar stock. A cone would be an angle. A tube could be a pipe. And from table, you can type in your coordinates to create your own custom stock. Here are our part materials. I'm going to stick with aluminum. I'm going to compute my boundary to wrap it around our part. We have a length of 102 and a diameter of 82. Now the model is not in position for machining, so we're going to reverse the model, and I'm going to move the subspindle coordinates to the backside. So on the left, we have our subspindle, and the right, we have our world. And CAD-CAM sized up our stock according to the part. Template management. Now for aluminum, we have several to choose from, and it is based on the type of tool that you select. So each tool is going to cut a little bit differently. We have bronze. There are a few templates, but they're easy enough to create. Over here, we have our tool information, and we can make changes anywhere here and set it as default. And CAD-CAM will create a new template for you. All right, we're going to create a turn work step. I'm just going to pick a template, make some adjustments. Tool number 25, offset 25. Maybe adjust our finish allowance, just on Z. Save as default. Give the template a name. Now, whenever you create a turn work step, that template becomes available. And as you can see, here's our adjustment. and your machining will be consistent every time. Okay, so we're going to talk about boundaries now. Over here on the left, you have full automation. EasyCam knows what to do with the turning tool. It machines from the stock boundary to the part. Below that, you have control of setting the left and right boundaries. And over here, you have inner and outer. So we'll go and use 3/4 view. This gives us the outline of the part. This is not a path. And as you can see, my cursor is grabbing certain areas. We grab, with snap to all, we grab intersections, lines, midpoints. So we're going to use left-right boundaries. We'll machine from here over to here. Let me just select the turn work step and just make my adjustment on the turn. So that's a good point. Over here in the list box in the upper right-hand side, you pick the operation. You do not have to go in the operation and manually set boundaries. It's just a matter of clicks. Let's look at our machining. Change over to outer inner. And I'm going to use snap to screen. You don't have to be accurate. And verify. There's our new boundary. We have automatic groove detection and crash control. As you can see over here on the left, we are picking up on all of the grooves. Regions that can be described as grooves in the outer diameter, the face, or the inner diameter are automatically detected. Now, as again, I had said that we are cutting all of the grooves. EasyCam automatically detects them because it's an external grooving tool. Over here, we have our boundaries where we'll machine one slot, and that's all based on the tool width. Now, in a curve system, that was the way we used to do it, you would have to click on the front face, clear of the face, a safety point at the size of the inside the bore, then come over and create your path, snap to the safe point again, and come out of the part clear of the face. Well, with the curveless system, we know to wrap it before the face. We come in at the clearance inside the bore, groove, and then we exit the same way we entered. So let's machine a part. Again, we start with 3D simulation. I'll stick with cylinder, aluminum, compute our boundaries, 90-degree diameter, 90-millimeter diameter, 152.4 for the length. Three-quarter view. Let's just take a look at what we've done for automation. Okay, we're inside the groove. New turn work step. We'll choose our template. Verify our machining. Let's see. New turn. There we go. Now we have material inside of our groove. We want to do another rough turn. I didn't fully define that first template that we had where we adjusted the tool numbers. We'll establish our boundaries. Use snap to all. Outer, inner. All right, cutting area not determined. That means we did not have skip groove turned off. That is a groove. Verify all again. Machining time. Now our next operation will be the grooves. We'll automatically detect those. External. Now those were automatically added to the part. Now I'll focus on a finish pass, which will be a profile. And we're going to turn off skip groove. We need to set our boundaries. Verify. All right, let's add an arc into the work with lead and ramp. I'll start inside the groove, so that would be 3 millimeters. I'll just put this window aside so we can look at our toolpath while the operation is open. All right, we can see that we're machining. We're starting on the left-hand side. So we go to the offset direction, change that to right. We have our sweep into the groove and our approach at 3 millimeters. Now we're ready to work inside of the part. I'll start with a drill operation. I'll select 26 for the diameter. Now, if I chose a drill that was larger than this bore, then CAD-CAM will stop at the shoulder so it doesn't violate the part. It's all automatic. Verify. And you can see that we're clearing the backside of the part, and our depth was automatically given to us. So let's just pick a point where I want the drill to stop. That gets copied to the clipboard. Paste that into our depth, and depth is positive. Now we're ready to rough bore. Let's just close this window. Let's see what CAD-CAM comes up with. All right, we're machining on both the right and the left-hand side. I'll save this side for the sub spindle. So we'll open up our work step. Let's see what skip groove does for us. And that's the tool path we want. Now we're set up for the groove. That is an internal tool. Set our boundaries. Okay, and you can see, like we had in the previous graphic, that we're starting outside the face, coming in at the proper depth or into the bore, and cutting our groove. Let's take a look at all of that using Verify All. That would include our tool change location, and we're going to inspect our stock. I do not see any rapid moves violating the part. So let's go into the stock setup. Because we have internal work, I'm going to check 3/4 view. Okay, now I'm going to give you a sneak peek to what's in store for you in one of our webinars to come on turn milling. Let us begin. Okay, that was a sneak peek of our turn mill product. We'll move on to some questions, but let me ask you a couple in advance. Are you programming by hand? Feel free to give us an answer. CAM has proven to be much faster. It's measurable. Think EasyCam. Do you edit G-code on a daily basis? Maybe from an existing CAM software where the posts aren't quite tweaked in. Our post processors are proven and designed to eliminate any editing. Have you been programming off of prints? A print is created by a CAD system from a solid model. Just as you saw in this webinar, be sure to request these types of files and import them directly into EasyCam. So now I'm happy to answer any of your questions. Okay, so how do I know which tool you want from all of these choices? Just a bunch of numbers and letters. Well, with the templates that we create, you're going to select the one, and there's actually a sneak preview as to which tool you're going to select. So let's just go back here. And you get to choose your templates. Let's go back, sneak peek here. Turn, choose your template. Okay, and then you can just look at the tool information to make sure you're selecting the proper tool and the proper strategy. What if you do not have a model? Many lathe parts are quite simple and we only have a drawing. Well, that would be a question for me to be able to create a custom video. We do handle geometry where that becomes a curve system like we have in the past. So you would basically follow the geometry with a curve. EasyCam knows where the boundaries are for that curve. So yes, happy to create a special video on that topic. Okay, demo on importing CAD. Let's see if I have something we can take a quick look at. Again, something definitely you can supply me with a CAD file, and that would warrant a custom video. So let's go here into okay, so here's a sample part. Came in as a DXF file. So we have to build a curve. And I'll use curve chain. I'll zoom in. I'll click the start and come over to the end. Add a rough turn. And we're using one of EasyCam's no path defined. Let's just add that to our work step. Let's just preview that again. You can see EasyCam's coming into the groove. Okay, skip groove is checked. Let's just verify that. That's for the solid models. So just a quick, we'll just add the groove here real quick. External. You have to create a curve. And here I'll use arc move and walk around the grooved area. Add that to our work step, curve number 2. So that's how you would work with geometry. It would work the same way as in the bore, but remember, you have to create the rapid move on your curve path. So if we go here, rapid is an option. You select a clear point, go into the bore, select another clear point, create your groove, and then you've got to add another clear point to make sure you have the proper exit. Okay, I'll just give it maybe a minute or more to give you guys the opportunity to think about it a little bit. Okay, well, I want to thank you again for joining our webinar. I'll keep you posted when new webinars come around. Thank you again. Take care. Enjoy.